Hey future engineers, today we are back with yet another tutorial. So today we'll be discussing how to make use of a breadboard in Tinkercad. So back to our website, hope you know how to get into it, and let us click on create, and as usual click on circuits. So that's been loaded. So here we can actually change our name to something else. So maybe this time use of breadboard. Okay, so I'll tell you what is a breadboard shortly. So if you want to just type in and search for breadboard, you can see there are many types. There are breadboard small, breadboard mini, and a large breadboard. For time being, let's maybe make use of breadboard small. Okay, so this is how a breadboard looks like. So a breadboard is a simple rectangular board used for building and testing electronic circuits without the need for soldering. So you can see the small grid-like holes, right? Okay, these are connected internally in rows and columns, allowing you to easily insert electronic components like resistors, capacitors, LEDs, and many others. So if you just look at it closely, there are 4 sections. To be practical, there are only 2 sections, but since there are like gap in between all these, I'll just put it as 4. So there is a gap here, a gap here, and a gap here. So these two, the extremes, are called the power rails. So there is a positive here and there is a negative here, a positive here and a negative here. So these are called the power rails. If you see these power rails, can you see a green line which is going parallelly along the other line? So these are all connected internally, which means that if you put a wire here, you can actually have an internal connection along these all lines. Okay, the same applies to the positive line as well. If you have a connection here, the whole line has this particular connection. So these two are power rails. Okay, the one which is there in the between, okay, these are called terminal strips. So this is the main area where components are placed. Okay, so consisting of columns. So these have columns like A, B, C, D, E, F, going till J. All right, and each row is electrically connected in set of 5 holes across the gap in the middle. So if you can see this, there is 5 holes. So these 5 holes are internally connected. As I said you, for power rails it is connected this way. For terminal strips it is connected this way. So that is the difference between these 2 sections. So I hope you understand what is the, how does a breadboard look like and what are the connections inside that. But if you see a gap here, these two are not connected. Okay, these 2 terminal strips are not connected. So if you have a connection here, it doesn't mean that you have the same connection here as well, unless you connect something from here to here. Okay, and make an internal connection here. So this is a separate connection and this is a separate connection. So that is the reason there is a gap here. The same applies here as well. So there is a gap here and there is a gap here. So I hope you understand what is a breadboard now. Now we'll see a small experiment, I would say an exercise. So in last session we had experimented how to blink an LED without the use of a breadboard. But this time, instead of using a battery, we'll be using a coin cell battery. Okay. So you know that we already have a positive and negative sections, positive and negative terminals for a coin cell battery. So we would be connecting this positive to the positive side of the breadboard, all right, and negative to the negative side. Oops, okay. Well, so I'll just have this alignment properly and over here as well. Okay, well, that's good. Now I can change the color from here. So probably I would put my power as red and my ground as black. So that will make it distinct and it is easier for you to read it as well. Now you need to connect an LED. Okay, so LED, it's right here. And I'm just placing it directly over here. So this is anode and cathode, as you know. Okay, maybe I'll just pull it across here. Okay, oops, okay, yeah. Now you need to connect both of these anode and cathode to the positive and negative of the coin cell battery. So as you know, anode should be connected to the positive. So I'm just taking a wire from here. So from wherever you take a wire from this particular line, okay, it is going to be the same. So I'm just going to take a line from here and putting it over here, which means that this particular anode is getting connected to the positive of the coin cell battery, because these are all connected internally, all right. And I'm going to change the color to red. Okay. Now the negative, I'm going to take a line and going to connect it to the negative part of the coin cell battery. Okay, and I'm going to change it to black. Okay, so make sure the connection, you get the connection right. Okay, the positive, that is the anode, is getting connected to the positive of the coin cell battery, and cathode, the negative, is getting connected to the negative of the coin cell battery. Okay, but one thing is that in my last session I had told you, like, if you want to make use of an LED, it's always good to make use of a resistor, because it resists the flow of current. Your small LED doesn't want such a large amount of current, right? So, but let's just run this code first and see. Yeah, so you have a warning message which says it is having like too much of voltage. So we'll just stop the simulation, and maybe yeah, instead of a negative, we'll just take this out and we'll put a resistor there instead. Yeah, okay, and I'll put a resistor here, but that should be connected to the negative. Please be sure of that. Okay, it should be connected to the negative side. Okay, so instead of a wire, we are placing the negative there. Okay, and putting the other side on the cathode side. Okay, now let us see if this works or not. Okay, so there's no warning message, it is blinking properly. Okay, but what in case if you want to place your resistor on the positive side? So what I do is that I pull a line as I did before. Okay, okay, and I'm just going to remove this particular positive line, and I'm placing the resistor to the positive side. Okay, so instead of that particular red line, I've replaced it with the resistor. Let's see if this works. Well, this too works. So you can place your resistor either on the positive side or on the negative side. It doesn't matter. So just when it is actually creating a circuit, it wants a resistor to resist the flow of current. So it doesn't mean, I mean, it doesn't matter if you want to keep it on the positive or negative side. So it can be anywhere, I mean on the positive or negative. So that's about it. Now, so this is clear for you, right? Now we'll just stop the simulation. Okay, now instead of having a coin cell battery, let's say we want a battery itself. Okay, so this is going to be the same as last session. So you can just flip it. Sorry, not flipping it. We are turning to the amount what we need. So here as well we have a positive and negative. So make sure your positive is connected to the positive of the breadboard, and negative is connected to the negative of the breadboard. And positive, I'm changing the color. Okay, so let's see if this works. Okay, I have not changed the circuit connection. Okay, everything is the same, but just that the power source remains different. Okay, so I'm just going to start the simulation again. Well, that still works. So this is how you experiment with breadboard. You can choose other color for LEDs, like maybe instead of red, I'm just going to choose maybe blue this time. Okay, and if I start the simulation again, it is blinking blue. Okay, so this is how it works. A breadboard is actually used to create simple to complex circuits. Okay, these are tiny circuits which we are dealing with, which can be even done without breadboard, but over the courses or over the sessions which we go through, we might have like complex circuits. So that is the time we need this breadboard. So make sure you always have a practice to use this breadboard while making any circuits. That's about it today. Stay tuned.